Hello, everyone. In this video, we're going to deal with the remainder and factor theorems. But before we go ahead and do that, we're going to do a quick review on polynomials just to make sure you're familiar with all of that. But if any of you are very comfortable with that already, you can just skip the first part of the video. So let's just dive right in and see what it says. It says that a polynomial is an expression consisting of several terms, generally written as a sum, where each term has a different power of x. Well, that's just a loose definition using simple words that are easy to understand. So let's go ahead and see what that means. Right here, we have 5x cubed plus 2x squared plus x plus 3. So the first thing you need to note is that it has 4 terms. All of them have been labeled. And there's some terminology that all of you should know. The first one is p of x. What does that mean? Well, what that means is that the name of the polynomial is p. We're just representing the polynomial with p. And in the parentheses, it says x. So, and the whole thing is generally read as p of x. It means that p is a function of x. Or again, in simple words, all that means is that the variable that we're using here is x. Now, the second thing is the degree. What is the degree of a polynomial? It's simply the highest power of the variable that you can see in any of the terms. So if you look at all 4 terms here, the highest power of x that appears is 3. So that means the degree of this polynomial is 3. Let's say if we could get rid of this term, now we're left with 2x squared plus x plus 3. Now the degree of this polynomial is 2. Okay, so that's just some basic stuff. And we've already talked about this part right here, that there are 4 terms in this polynomial. Let's move on. The first term, what does a term actually mean? Well, you see, they've been underlined right here. This is the first term, then 2x squared is the second, x third, and then 3 is the 4th term. And again, those have been broken down right here for you, term 1, 2, 3, and 4. And each term is of the form a times x power n. Now again, what generally students have a difficulty in looking at general forms and understanding what those mean. So a is just a constant. What do we mean by that? That it's just some number. It could be 2, 5, 6, 7, and so on and so forth. And n has to be a positive whole number for something to be considered as a polynomial term. Well, what does that mean? That might be a little confusing. If we go back again, let's see if this polynomial right here meets those conditions. We said that each term has the form ax power n, where a is a constant and n is a whole number, and it should be a positive whole number. So you see this a is a constant, and the power of x here is a whole number, positive whole number. That's fine. Same thing, constant is 2, power is positive 2. Over here, the constant is plus 1. So again, that's fine. The power of x here is 1, which is also a positive whole number. So all the terms are fine. So this is actually a polynomial. Now, if we come down here, if you look at these 3 terms, 1, 2, and 3, well, these are not polynomial terms. And we want to see why. Well, the reason for that is that if you look at the power of x right here, the power is -3. It's not positive, so that's not a polynomial term. The second one, the problem is that the variable x is in the denominator, and that is also not allowed, so that's also not a polynomial term. And again, another way to write this is just x raised to the power of -2. So you see, the power right here is not positive, so it's not a polynomial term. If you look at the third one right here, well, is that a whole number? It clearly isn't. 3 over 2 is basically 1.5, which is not a whole number. So that also is not a polynomial term. Well, what do you think about this one? Some of you might say it's not a polynomial term, but this one is fine. It is a polynomial term. Why? Because if you look at this part right here, that's just a constant. The constant can be any number. It doesn't really have to be a whole number. So that the first part is being met, meaning the condition on A is being met. Now, when we come to the condition on N, it has to be a positive whole number. Is this a positive whole number? Yes, it is. So there you go. This is a polynomial. It's an acceptable polynomial term. So that's pretty much wrapping up just the basic stuff about polynomials. Now, the final thing we want to talk about is what the coefficient is. Again, I don't have to read what's on the screen in front of you. You can just do that by pausing the video. Mainly, all it means is that whatever is written next, right next to the variable that you're dealing with is actually the coefficient of that variable. Now, what do I mean by that? If you look at these two examples right here, let's say our variable of interest is 60x. Sorry, not 60x. The variable is just x. If the variable is x, then the coefficient of x in 60xyz would just be 60yz. And the coefficient of x in this term right here, 20 times m times x, would be just 20m. Now, one thing that I want to point out is that an easy way of checking the coefficient of a variable in a given term is to ignore the variable and see what's left behind. I'll just show you how to do that. Let's say we're talking about 6x, y, z, and we want to see the coefficient of x. What that means is that if you can just use your finger to cover the variable that you're looking at, then everything else that's left in that term is going to be the coefficient. And, you know, let me try to simulate my finger. So if you put your finger on x, you just basically block it. You can't see it anymore, right? So let's block that. So there you go. If you ignore the x, what are you left with? You're only left with 6 times y times z. So there you go. The coefficient of x in this term is 6yz. And the polynomial that we wrote above, right here, the coefficient of x cubed is 5, coefficient of x squared is 2, coefficient of x is 1, and the coefficient of the constant term is just 3. And basically that's what I've written down here. Now you have to realize that the final term only has a 3 in it. So when you have a constant term, what is the power of the variable in this term? Well, there is no variable right here. It's just a number 3. So one way to write it is that if you want to multiply it with something that has the variable, there's only one way to do it. The power must be 0. Why? Because x raised to the power of 0 is going to give you 1. So 3 times 1 is just 3. So whenever you have a constant term, the power of the variable in the constant term is 0.
Okay, so we're now going to look at division, 2 cases of division, one using numbers and the other using polynomials, because it's very closely related to the remainder theorem. And then we'll just go ahead and state the theorem and see how to use it. So the first thing we're going to do is divide 37 by 5. Let's just do it quickly. It's pretty straightforward. You multiply by 7. That gives you 35, and you're left with 2. Now, the main thing is that we want to label all these numbers and see what they mean. So this 2 is the remainder. The 7 is the quotient. 5 is the divisor. And 37 is the dividend. Now, what do all these terms mean? Well, the dividend, the main one, is what we're dividing. And then the divisor 5 is what we're dividing by. The quotient basically means what is a number by which you need to multiply the divisor to get as close as possible to the dividend, or maybe just exactly equal to that. What does that mean? For instance, if you do 35 divided by 5, well, that is just 7. So in that case, you wanted to get to 35, you multiply 5 by 7, it does give you 35. But in the case that we're looking at right now, we want 37. So we've multiplied the 5 by the 7. It gets us to 35, but then we're still 2 units away from our number. So that means after multiplying the 5 by the 7, we'll have to add 2 to that to get to 37. So if we just formalize that right here, what it means that we can derive a general relationship between all of these terms we've mentioned. So the dividend is equal to the divisor multiplied by the quotient plus the remainder. And does it work in this case? Well, we can quickly see. The divisor is 5, quotient is 7, remainder is 2. That gives you 35 plus 2, which is 37. And this, the dividend also was 37. So yes, it does. It does work. Now we're going to do the same thing with polynomial division and see how it's related to this. Okay, so onto the polynomial division now. This is what we have: x squared minus x plus 3 divided by x plus 1. What we need to do is, the first thing we do is we look at the term with the highest power of x inside the division sign, and then we see the term with the highest power of x outside the division sign. In this case, inside we have x squared, outside we have x. And x squared divided by the x just gives you x. That means that's what we need to multiply the divisor with. And if you remember, this is the divisor. So we write x above right here. Now we multiply this x by the x plus 1 out here, which will give us x times x will be x squared, and then 1 times x will be x. So that means the overall, the product is going to be x squared plus x. So we just go ahead and write it underneath. And what we want to do is subtract this from what's above it. So x squared minus this x squared, these two go away. And then you have minus x minus x. That gives you negative 2x. And then you bring down the next term, which is 3. So you have minus 2x plus 3. Now you do the same thing. Highest term in x here is 2x. Sorry, negative 2x. Highest term in x here is still x. And negative 2x divided by the x is negative 2. So you go ahead and write the negative 2 up here. And then do the same thing again. You need to multiply the negative 2 with x plus 1, which gives you minus 2x minus 2. And you want to subtract again. Now, once again, this negative 2x goes away with this because minus 2x plus 2x. And then you're going to be left with plus 3 minus minus 2, which becomes 3 plus 2. And that is 5. Now let's quickly go ahead and put the labels here again. This is the remainder. Okay, so you see these two parallel cases, the reason why we looked at numbers first and then at polynomials is that people are a lot more comfortable dealing with numbers compared to polynomials. Now, if you look at the left and the right, all these terms that we've labeled here and here, there is actually no difference. They're all the same and in the same positions as well. You see the remainder is down here, the remainder on the left is down here as well. And this equation that we've written down, that the dividend is equal to the divisor times the quotient plus the remainder, is going to apply exactly in the same manner to polynomials as well. X squared minus x plus 3 over x plus 1 as x minus 2 plus 5 over x plus 1. And this will always work for you. So you write the quotient plus the remainder divided by the divisor. Now, what you can do for just for practice is that you can take this stuff on the right, do the algebra, and then see if you get the same thing on the left. If you get the same thing on the left, that means your long division is correct. Otherwise, it's not correct. Okay, so coming on to the remainder theorem. What is the remainder theorem? Basically, in just loose terminology, just to make sure that we're not using technical terms and making it more difficult for you to understand what it is it just provides us an easier, a direct way of finding out what the remainder is when we divide a polynomial by a linear factor. And that's really all there is to know about it. And what's a linear factor? X minus 1, x plus 2, these are both linear factors, but then x squared plus 2 is not. Why is that? Because x minus 1 and x plus 2, they both have a power of x of 1. And when you have a power of 1, that means it's a linear expression. So the expression is linear in x because that is the variable that we're dealing with. Let's look at what a formal statement says. It says, when a polynomial p of x is divided by a linear divisor x minus a, the remainder is given by p of a. And that's all there is to know regarding the remainder theorem. And you just need to know how to use it. That's what we're going to do next. So what is p of x? We said p is just a polynomial that we're talking about. If you remember, we talked about this and we talked about what p of x also is. Now, coming to this right here, what is p of a? It means you have to evaluate the polynomial p of x at x is equal to a. Now, if that's a little too technical, all it means is that you look at the polynomial that you have for p of x, and in that polynomial, everywhere you see x, you just plug in a in place of the x, and you're done. So in this question, this right here is your p of x. This is the main polynomial that you're dealing with, and you're dividing it by this. So this is x minus a. Now, we just said right here that we want to evaluate the function at a, meaning we want to find out p of a. If we can find out p of a, that means we know what the remainder is. So naturally, the next question then is that what is a? Well, one easy way to find out what that is, you can just set the divisor equal to 0, and whatever value of x that gives you, for example, in this case, it gives you x is equal to 1, that would mean that a is 1. Again, what does that mean? That means we have to evaluate p of x at x is equal to 1. So in other words, we just go ahead and find p of 1. How do we do that? As I mentioned before, everywhere you say x in the polynomial, you just go ahead and plug in 1 in place of the x. So 4 times 1 raised to the power of 3 minus 5 times 1 plus 1. This is 4 minus 5 plus 1, which is 0. So that means the remainder when the given polynomial p of x is divided by x minus 1 is 0. Let's quickly do the same thing for part B. This should be quick. We just have to do p of 2 because now in this case, x comes out to be 2. That means a has a value of 2. That's the value at which we're going to evaluate the function. So this is what you get, 4 times 2 cubed minus 5 times 2 plus 1. What is that? 4 times 8 is 32 minus 10 plus 1. That's going to give you 23. So that means your remainder now is 23. So I want to bring to your attention one thing. Hopefully you remember that when we started with this lesson, let's see. Yep. So this is the first polynomial division that we did. And when we did that, we saw that the remainder came out to be 5. Now that we're equipped with a new way of finding the remainder in the case of polynomial division, we want to put it to the test and see if it really works. So let's just quickly do this problem using the remainder theorem and see if it still gives us a remainder of 5. in this example over here, we're dividing by x minus 1. That means we want to evaluate the function p, which is right here, at x is equal to 1. So when we do that, we get 1 squared. Sorry, this is x plus 1. So we're going to evaluate the function at p of minus 1. So x has to be negative 1, not plus 1. So it's minus 1 squared minus minus 1 plus 3. And if you're a little confused as to what's going on, it's just x squared minus x plus 3. And everywhere you just plug in x is equal to negative 1. So what does that give you? 1 plus 1 plus 3, that is 5. So there you go. It does work. That means it's, you know, in agreement with the polynomial division. So we've confirmed that yes, it is true. What we're doing does make sense. All right, so that brings us to the next thing, the factor theorem, which this, again, just to put it into simple words, is a sort of extension of the remainder theorem. And what does it say? It says if x minus a, the linear divisor that we're dividing some polynomial by, if that divisor is a factor of the polynomial, then p of a is going to be equal to 0. Now that might sound a little fancy, but it's very obvious. And I'll show you why. Firstly, what is this p of a? If you can recall just what we did just now from the remainder theorem, this always gives us the remainder. And from basic math, you know that when something is a factor of another thing, or, you know, no, that's a little confusing. If a is a factor of b, then that means when you divide b by a, the remainder is going to be 0. Again, let's just look at it in concrete terms. So 35 divided by 7 gives you 5. What's the remainder? It's 0. What does this tell you about 7 and 35? That 7 is a factor of 35. And the other example we used above was 37 divided by 5. And in this case, the remainder came out to be 2, which is not 0. So what does that tell you? 5 is not a factor of 37, right? So that's all the factor theorem is telling you, which is obvious, that if the remainder is 0, then that means the linear divisor is a factor of the polynomial. Otherwise, it is not. And if you want, we can just write it like this, that the remainder theorem says that R, the remainder, is equal to P of A. And we know that if the remainder is 0 in the case of division just generally, then that means the divisor is a factor of the dividend. So that directly leads to this, that P of A has to be 0 for x minus a to be a factor of P of x. So as usual, we're going to look at a couple of very simple problems and see what the factor theorem is saying, how to apply it. So we have to determine if x plus 1 is a factor of this entire polynomial. Now, what do we need to do? Again, let me break it down for you a little bit before we just dive right in and solve the problem. And by the way, one thing that I've felt is that a lot of students will just look at a math problem and just jump right in and try to solve it as quickly as they can. The problem is, if you don't have a roadmap in mind, if you don't know what the scenario is, what's going on, what needs to be done to solve the problem, you're pretty likely to get stuck in a reasonably complicated problem. What you need to do is you need to make sure that you read the question carefully, you know what is being asked, and you know fundamentally what concepts or what kind of knowledge you need to draw upon in order to solve the problem. Let's try to do that with this. It's a very basic problem, but still let me try to tell you what the thought process would be if I were to do it. Now, I want to determine whether this is a factor of this polynomial right here. Now, one thing that I do know is that I can do that by checking the remainder. If it comes out to be 0, I'll say yes, x plus 1 is a factor. If the remainder does not come out to be 0, I'll say no, it's not a factor. That means I just need the easiest possible way to find the remainder, which exactly comes from the remainder theorem. So that means the remainder here is going to be given by p of minus 1. So let's just quickly evaluate the polynomial at minus 1. Minus 1 raised to the power of 3 minus negative 1 squared plus 3 times negative 1 plus 2. And what is that? 3 minus 1. And then this one right here gives you a plus 1 when you square it. But then there's a negative 1 here. So overall, it's a minus 1. This gives you minus 3 plus 2. So 3 goes away with the negative 3. Minus 1 minus 2 plus 2, that is 0. So what have we done? It means when we divide this polynomial by x plus 1, the remainder comes out to be 0. So yes, we say x plus 1 is a factor of p of x. And what is p of x? It is this whole thing. And then part B, the same thing. We have to determine is if x plus 1 is a remainder of this polynomial. We can quickly do that as well. We evaluate this one at negative 1 as well. Minus 1 power 6 plus 2 times negative 1 times minus 1 minus 4. That gives you 1 minus 2, multiplying these two, and inside the parentheses you have minus 2, negative 4. So 1 plus 4 minus 4, that gives you 1. So what is this telling us? That the remainder, when this polynomial is divided by x plus 1, is 1, which obviously is not 0. That means x plus 1 is not a factor of p of x. So you see, that's what I mean when I say that the factor theorem is just an extension of the remainder theorem. If you know the remainder theorem, it's just one step forward and you have the factor theorem. Okay, so that's pretty much it for this lesson. I have this question right here. You can see the reference at the bottom. Again, I'm not going to solve this, but let me just write it down. So I'm going to do a part 2 on this, in which we're going to talk about synthetic division, which is a really quick way of doing division, and it's an alternative to long division. And I really like using that in the case of linear divisors especially. Now that you have to try this problem on your own, again, what I'm going to do is try to tell you how I would solve this problem, or what would be going through my mind if I were solving a problem like this. It says, let's just read it together first. The polynomial of this whole thing, where a and b are constants, is denoted by p of x. It is given that 2x plus 1 is a factor of p of x, and that when p of x is divided by x plus 2, the remainder is 9. Now, a lot of people sort of get lost in all the text. What you need to do is just make sure you can pick out the important information. Well, the first thing is right here. That's the polynomial we're looking at. This is the first divisor. It says it's a factor. Second main thing you need to look at is that the other divisor they're talking about is x plus 2, and the remainder is 9. So basically, what is the question giving us? It's given us a polynomial, p of x. It has given us 2 divisors and their remainders. Now, obviously, since we're doing remainder and factor theorem, that means those must be required in this question. So with these two sets of values, we can do what? We can make two equations because the remainder theorem tells us how to relate the divisor to its remainder. And we have that. And what are we expected to find? We want to find A and B. So what I would think is that, okay, this is all the information that's given. I need to find two unknowns. That naturally means how many equations do I need? I need two equations. Now, where are those two equations going to come from? They are going to come exactly from these two sets of values that we have. Sorry, it looks a little messy towards the end. I'm probably trying to rush. Now, let me just form those two equations for you, and you can do the rest yourself. Okay, let's keep this in view. The first divisor is f of x, 2x plus 1. Remainder here is 0. That means p of minus 1 over 2 should be 0. That's going to give you your first equation. Second divisor is x plus 2. And the remainder in that case is 9. So that means p of minus 2 is going to be 9. That's going to give your second equation. You're going to solve them simultaneously to find a and b. Okay, so hope you enjoyed. In the next lesson, we're going to do synthetic division and some more problems on factor and remainder theorem, which will be a lot more complicated than the ones that we've seen so far, to add on to this video.